So the reason I wanted to actually connect my computer is because I wanted to show you Shifter in action, how it performs and how you can use it on Blue Waters. So once again, my name is Maxim Belkin. I'm an education and training coordinator, and I will be talking about Shifter. So first of all, what is Shifter? Shifter is a Docker-like solution. It's not really a Docker. It's a separate product. And what it does, it basically brings Docker or containers to HPC systems like Blue Waters. And it actually serves this purpose not like for all HPC platforms, only for Cray. Why do we need containers? Let's imagine we are building our application and our application uses some libraries like FFT, and it also uses system libraries. And what happens if you try to port it to another computer, which might be a supercomputer? Some libraries might not be available, and as a result, your application will not run. And this is actually the idea behind containers, is that instead of trying to bring like a source code only of your application, you bring the entire stack. And as a result, you get your software running on a supercomputer. Now, of course, it looks that simple only on a slide. In fact, it's a little bit more complicated. And yes, so your application might be, you might be working in CentOS or Ubuntu or any other operating system, and it will work regardless of which operating system you are using. Linux, of course. So once again, Shifter is a container solution for HPC systems, and I should have added here Cray HPC systems. It's developed at NERSC, and it's open source. You can find source code on GitHub. It works with Docker images, but not only. It's not limited to Docker images. The most important difference between Docker and Shifter among some security concerns is that Shifter images are optimized for fast redistribution across compute nodes. And you have to understand that if you plan on running a job that uses 1,000 nodes and you use image that is let's say a gigabyte, you would have to send 1 terabyte data, and it would be like a very heavy load. And Shifter images, they are optimized so that this task is not that difficult or heavy. Now, Shifter allows us to use software stacks, and it is integrated into Blue Waters as a module. Of course, it has a limited functionality because it's like a subset of Docker. So there are things that you can do in Docker but cannot do in Shifter. But at the same time, those downsides are really minor. Once again, how can we interact with images? So here you see the standard interaction procedure of users with the system, with the Blue Waters. First of all, you have to connect to the system using SSH, and when you SSH to a compute node, you get onto a login node. Then you have to use a qsub command to get onto a mom node, and from a mom node, you can get to a compute node using ap-run. And Colin emphasized the importance of using ap-run in order to not abuse mom nodes. Now, how many of you know the difference between Cray machine, like Blue Waters, and other standard clusters? What's the main difference in terms of these nodes. So the main difference is that Cray system has dedicated mum nodes. Other computing systems, HPC systems, mum nodes, all compute nodes are also mum nodes as well. So Blue Waters has 64 mum nodes, and given that there are thousands of users, it is very important not to run compute-intensive tasks on mum nodes. That's why it is very important to use AP-run. And Shifter is actually, on Blue Waters, you can use Shifter only on a mum node. So you can interact with it only on a mum node. Okay. And during this talk, I will be using UDI, which stands for User-Defined Images. So keep in mind. Okay, so first things first, we have to get a Docker image onto Blue Waters. In order to do that, we need a very short interactive job. And this is the typical syntax that you can use. You can use only one processor on a node. Once you are on a mum node, you can load this module. And this is when you can start using get Docker image command. This command has 3 subcommands: images, lookup, and pull. So images, and yes, and I will go over all 3 of them in a few minutes. But the point here is that Docker image name follows a standard Docker convention. You have repo, or usually it's your username on Docker Hub, and then image name colon tag. Okay, let's take a look at all the commands. Get Docker images. Basically, all it does, it prints you all the images that are currently available on Blue Waters. It prints their names, IDs, sizes, and so on. Below you can see like an example of such an output: CentOS 5, 270 bytes, and so on. Next command is lookup. Lookup checks for you whether the image you want to use exists on Blue Waters. If it exists, it prints you the related information. If it doesn't, it basically gives you an error. Get Docker image pull downloads image from Docker Hub and prepares it for execution. Basically, what it means, it downloads the image, Docker image, and it translates it to the format that it understands. I have to point that it is very important to wait and not cancel this process, because once the image is downloaded, it takes time to process it, and you will not see output for maybe a minute or so. And it is very tempting to to hit Control-C to cancel it. Don't do that, because next time you start the job, you'll have to wait again. Of course, not that long, but still, this process has to be completed. Now, what do I do if image is not on Docker Hub? Well, the solution is easy. You have to just upload it to Docker Hub. There is no other way, unfortunately. So I'm just showing here very simple 2 examples. You can pull image from repository, or you can from some other, for example, private repository, and then or build it yourself on your machine, and then log into Docker Hub using Docker login, and then send the image to the Docker Hub. Now, let's talk about, and the reason I'm going very fast, because I want to show it in a live session in the end. So you will see all of that again. So first we have to submit a job, qsub, with appropriate parameters. Once we get the mom node, we have to load shifter module. And we can start computing. The syntax is as follows: ap-run -b. So -b tells ap-run to not copy the executable that you will specify in the end. What usually happens is that when you use ap-run copies your executable to every compute node. With -b, it does not do that. And it is important to use it with the shifter. Then you specify the number of MPI ranks, number of ranks per node. Those are -lowercase n and uppercase n. Then you write --, which means that after that there will be no options for ap-run command. Anything that follows from the first, from here to the right, will be a command. And this is where we use shifter. We say shifter -image equals Docker, colon, and then the name of the image, Docker image that we downloaded. Then again, we use yet another --, command to signify that whatever will follow will be actual command that we want to run inside of a Docker image or shifter container. And that's it. You can mount directories that are available on Blue Waters. For example, if you keep your data in a special directory which is not included into the Docker image for some reason, you'll have to check whether it is included or not. But you can add external volumes. Just make sure that directories that you specify exist. Otherwise, it will give you an error, but it will not fail. So it will just inform you of a problem. Now, this syntax is great, but if you're using shifter to run some single node jobs and you basically want to improve your, or maybe you have to use a certain image many times, then entering shifter -image -volume might be a troublesome thing. And instead, you can specify everything when you start a job. So to do that, you add a special generic resource request. And the way to do it, you add -l gres, generic resource, equals shifter. When you do that, Torque will know that it has to invoke special scripts to prepare shifter. The next thing you can do, or in fact, yes, you can do. You can omit this step, but you add -v, that stands for environment variable, and you say UDI equals which image you want to use. Note, by the way, that when you specify UDI, you don't have to add Docker colon. And you have to do that when you use shifter directly. Now, finally, the step that actually makes sure that you, when you call ap-run command, you will be using actual image, shifter image. You specify cray _ rootfs environment variable, and you set it to UDI, which is pretty easy to remember. And here you go. So you can, So you can start using ap-run directly without any shifter commands. Just don't forget to use -b flag. That still applies. Yeah, that's the second way you can use Shifter on Blue Waters. And this is an example of output. So once we are on a mom node, we can check which, for example, bash version we have. And you can see that it says bash 3.2, which is pretty outdated. But if you do the same thing on a compute node, you see that bash has a version 4.2. And this is a confirmation that we are using an image, Docker image. Okay, you can do all of that, not on a command line, but in a script. This is an example of a script, and there is nothing new here. So all we do here is we say that, okay, this is a bash script. If you don't know, in fact, you can write submission scripts in any language. It's just that these commands, BBS commands, should be in this form. Okay, so we say that JIRAS equals Shifter, to say that we will be Shifter, UDI, which image we want to use, number of nodes, number of processors per node, what type of nodes we want, XC, so without GPUs. And this is an example how you can use two API run calls in a single script. I think that's what Colin said, that there are a lot of 15-minute jobs. This is how you can use more nodes, and you can pipe them together as well. Well, piping is a different thing, but one thing to note, there are special directories that are mounted, that are mapped from the Blue Waters onto the container. Those are projects, Scratch, and home folders. You don't have to do anything to do that. That's actually the step that Blue Waters script does for you. One differences that I haven't mentioned so far is that in Docker you can be root, you can do anything you want. That's not the case in a Shifter. In Shifter, your username is the same as on Blue Waters, and you have no special privileges. You can SSH to a compute node that runs Shifter, and to do that, you basically generate a key pair. First of all, you can create a directory .shifter in your home folder, and you generate RSA key pair with empty passphrase. The second point here is I'm showing you how to get the list of nodes that are assigned to your job that you got. Usually you would get something like NID 0003233 or something like that. Okay, and finally, to SSH to compute node, use this simple command, SSH-p 204. Of course, everybody knows that you can use a config file for that purpose. Basically, you create a config file, and this config file, you can use this config file to SSH to compute node. The only thing that you have to know is that that config file has to have proper permissions. Only you should be able to read it. And read and write, of course. Okay, now this is the most exciting thing, at least for me, because I struggled with it for quite some time. How do you make MPI work with Shifter? And the challenge here is obvious. So inside of a container, you can have any software you want. You can have MPI, you can have OpenMP. That's not a problem. The problem is is how do you use actual high-speed network that Blue Waters has? Because if you are using non-optimized libraries, your code will be slow. And the idea that Shifter team, along with the Cray team, well, of course, mainly Shifter team, but what they came up with was that they have to use MPeach ABI compliant version of MPI. In simple terms, what it means is that there are certain implementations of MPeach or Cray MPI that use the same underlying words, and they can understand each other. For example, if you have a library like MPeach MPI library, which is ABI compliant, Cray MPI library, which is ABI compliant, will understand calls that user issued to that MPeach library. I know it's a little bit complicated, but basically the main idea, main take-home message is that you have to use MPeach ABI compliant version of MPI inside of your container in order to use Blue Waters interconnect. Fun fact, you cannot use a Cray programming environment. You have to use either Intel or GNU. Another thing is that your image has to have a glibc version 2.17 or above. And I'm giving you examples of distributions that have this glibc. And here you have to use tort batch prolog integration. And this complex phrase means that you have to specify -l grs equals shifter, -v udi equals image on the command line, or in a script, of course. So you cannot use shifter itself in the job script. At runtime, you have to set LD library path to the location of MPeach ABI compliant libraries, and a little bit of magic, and I will show you this magic in a couple of slides. Now, this is an example of Docker file that I created for this for today's tutorial. Basically, what I'm doing here, I don't know how many of you know Docker, but because this is an introduction to Shifter, I assume that you might know what Docker is. It's very easy to read. The first line says that I'm basing my work on a CentOS 7 image. I'm just saying whom to contact if you have problems with this image. I'm adding a label, maintainer. Then I install a few things that are not in that image, and I will need them. And keep in mind that at this moment I'm root here. When I will be building an image, I will have root privileges. And the next run command here, basically what I'm doing here, I'm downloading MPeach 3.2, which is ABI compliant. I extract it, untar it. I go delete the source file that I downloaded. I go to that directory. I configure, standard procedure, configure, make install. I have to point out that the reason I use these line continuation symbols, like ampersand, and slash, in order to reduce the size of the image. So in principle, you can do all of that, all of these commands using separate run commands, like run cd, run wget, run tar, and so on. But the caveat here is that when you delete, for example, when you do run rm, it just, Docker creates a layer that masks those files. And there is, as a result, your image will be large, even though it can be much smaller. That's the only reason I use ampersand slash. The next run, what I do here is I download some benchmarking program, and again I install it. Also, I create a directory called test-mpi, and test-mpi will be created in a root directory. So you can do whatever you want because you are root at this moment. I copy a file from my computer, which is located in files directory, to the image. I change my working directory using workdir to test-mpi, and I compile it. That's all. Once we've prepared this file, you can build it and push it to the hub, Docker hub. And this is the content of test program, just so that you see this is a simple MPI program, nothing special. We are just saying hello from this rank and so on. Now, MPI, this is a magic part. MPI, how do you use MPI applications programs with Shifter? So first, you submit a job. As I said, you have to specify these requests on either on the command line or if you are doing that in a script. And you can use, by the way, if you can remember, this is the name of the image that I've prepared for this tutorial. You change your directory as usual, that's standard script. You change your working directory to where you submitted your script from. Load Shifter, obviously we will need that. We have to unload the default Cray environment, programming environment, unload CCE, load GNU or Intel. In this case, I'm loading GNU because I was using GCC in my Docker image. Unload Cray and Peach and load Cray and Peach ABI. So Cray-mpeach-ABI is the ABI compliant compiler MPI implementation that I will be using actually. Now, we have to set, you remember I mentioned that we have to set that LD library path, and in order to prepare for that, we will store Cray LD library path, and we will add some VLM path. So, WLM path. So WLM, as we found out, stands for Workload Manager, and it will be needed inside of, in order to make use of several nodes at the same time. So cache, this is the directory where we will copy all the libraries that we will need. We have to create this directory first, of course. And this is the step where we copy all these libraries there. We set LD library path. We export Cray root fs to, we set it equal to UDI. And we can run, finally, we can run our MPI code. But notice that I'm not using Shifter or anything like that. I'm using directly ap-run. I'm saying ap-run-b -n64, 64 MPI ranks, and my executable. One thing to remember, once this command completes, you have to make sure that data that it produces is saved either in your Scratch, projects, or home directory. Because once it's done, whatever you created in other directories will not be saved onto the Blue Waters machine. So run this command from a projects folder, from a Scratch space, well, from Scratch, yes, not from projects. and then copy data back to projects. That's it. Thank you very much. I'm not sure if you want to do the live session. I can do that, and I have it like everything is ready, just to show you how it's done live. But probably we are fine without it. All right. Thank you.
Any question from audience?
Thank you for the wonderful presentation. Yes.
Max, do you guarantee that those commands you showed us work?
Yes.
Okay, then we'll skip the live ones. But I want your word on it.
Yes, because you see that this is obviously a non-obvious thing to do, like all of that magic with the shifter and stuff. But I tested it like perfect. Yeah. Yes.
So question, on the slide where you had the two AP runs in there and you had a -N16, a capital -N16.
Yes.
So if I do this with a regular MPI program, I'd get 16 copies of the executable started. So with Docker, what do I get? Do I get 16 copies of the executable running in the same image, or do I get 16 images?
I'm sorry. So here, do I get what?
Do I get 16 independent file system images, with each one with one copy of the executable running inside of it, or do I get 16 copies of the executable all seeing the very same file system?
Well, it's good that you're asking about this line, because honestly, I think I made a mistake here. You can run only one shifter per compute node. Only one shifter executable. So if you try, so here I'm just saying that this line AP, well, actually no, I didn't make a mistake. This line just says that this shifter image will use 16 cores on a node. That's it.
Yeah, but I think it would still fail because only one app run per node, and you have two app runs per one node now. You only have one node to play with.
Yeah, and I have just one node.
Right, but two app runs. But two app runs, so it will fail.
That's right. That's why it will fail. Yes. Yes. So yeah, this is actually yeah. I'll have to remove that because this is originally I had different example, but I decided to change it for Blue Water. So the mini tutorial was prepared for JYC. This is a small Blue Water system. And on JYC, we have a different requirement that we have to use two nodes. When I translated the script to Blue Waters, I decided, oh, sure, I'll use just like default one node, but I forgot about the shifter thing. And when you asked, I just recalled that no, there can be only one shifter prompt command on the per node. All right, thank you very much. Yes.
So what is the interoperability between the shifter and the Docker for the same image? Because we just want to create one image and it can run both on HPC and run the personal computer with just Ubuntu hosting system.
And that's what you will be doing. Once you have your image, you upload it to Docker, Docker Hub, sorry. And let me show you this example.
So maybe one comment. The difference that you will probably run into if you're used to Docker, the images on Blue Waters are read-only because they're literally disk images. You can't store data in that image. You can only store it in the home directory, scratch directory, purchase directory that you see, and in temp, which is mapped to just memory, but not into the Docker image itself. So not into any directory that you would normally do.
That is for the security, right? No?
Oops.
Okay.
So this is how, I don't know if you can see that. This is how you would download an image. Well, it's enabled, probably created a different one. Let's try this one. This is what happens like when you pull an image. So first of all, you see that it's much quicker than connection here because Blue Waters has a very high-speed connection to the internet. And you see that it froze, but I'm not canceling it because it does the conversion of that image to the format that Blue Waters understands, that Shifter understands. And this is important to wait for that. I mean, you can wait for like a minute or two. If it runs for longer than 5 minutes, definitely kill it because it's probably finished. It's just doing something weird. But you will be using the image from the Docker Hub. And Blue Waters stores this image and it can update it. For example, when you update image on Docker Hub, you push it to Docker Hub and you pull it on Blue Waters. That's terminology, that's Git terminology. You push and pull. Yes, so.
Image, does the image have to be, can the image be a private image on the?
It can be, if you have access to that.
Yeah.
So if it's private, in a private repository,
Yes.
So that has to be from a public.
Yeah, because I think you mentioned that it has, the only way to get the images from the Docker Hub, right?
Yes, so my example was that you download it from a private repository, push it to public repository on Docker Hub, and then push it on Blue Waters.
Yeah. So is there any way to just download it from a private repository without publishing it? Is that possible?
There is, but not with the Docker Hub, from different ones.
Okay, I see.
I will be translating all of that material to documentation at some point, at which point I will be checking like everything in terms of what you can do, like which repositories you can use. And I will make sure I will check to check private repositories.
Okay, so thanks, speaker again.
Thank you.